Hello everyone, let's solve today's POTD. So in today's POTD the question is not clear and I think most of the people of you will not be able to understand the question. So here is the question. We are given an array integers or array of integers and we have to do the following operation until a single element left for the single element left. Okay. For the kth operation what we have to do, we have to rotate the vector by 1 clockwise and delete the kth element from last until there is only one element left. So as you can see, like after half of elements will be deleted, k will be greater than the array vector size, right? Like okay, let me explain you the logic behind it. Suppose here is an array 1, 2, 3, 4, 5, 6. Okay. So what it is saying for first k is equal to 1. So we rotate by 1. So this 6 will be here, right? So it will become 6, 1, 2, 3, 4, 5. And now we have to delete kth element from last, mean first element from last. So this will be deleted. So for k equal to 2, what it will become? We have to again swap, rotate by 1. So this 4 will appear on the front side. 4, 6, 1, 2, 3, right? Now again we have to delete second element from last. This first element, this is second element, this is deleted, right? Okay. Now for k equal to 3, what we have to do, we have to again rotate by 1, so it will become 3, 4, 6, 1. Agree? Okay. So now we have to delete third element from last. This is first, this is second, this is third. Now this is deleted. So now you can see our remaining vector is 3, 6, 1, right? If you rotate if you rotate by 1, so it will become 1, 3, 6. It will become like this because first will appear on the front side after rotation. Okay. So now we can say there are only three elements. So how can you delete the fourth element? Because we have to delete kth element from last, but there are totally three elements. So how can you delete the fourth element? So that's why I'm saying that there is a one mistake, or you can say not clarification in the question. So there will be one another option here, like that key if there are no k element in the, like, if number of elements number of elements, like you like, okay, if size of vector is less than size of vector is less than k, delete first element. Okay, after rotation delete first element, not kth element. Okay, rotate this, delete the kth element from the last if size is greater than k, otherwise this. So one of the following operation we have to do: if size greater than k, then delete the kth element from last. If size is less than k, then delete the first element. Okay, so now what we will do here. Okay, now what we will do, there is no four elements in the left size 3, so we delete this first. Now what remains? 3 and 6. For k equal to 5, after rotation, what it will become? It will become nothing but it will look like this. Agree or not? Right? So again, there is size is 2 and k is 5, so we cannot delete fifth element. So we will delete the first element. So this way there is only 3 is remaining. So this way we have to solve this question. So it was a mistake in the question. So Now the question is clear. So we will insert this last element here, because after rotation this element will come here. And now delete the, if size is greater than k, then delete the kth element from this side. So now this, after this, like after rotation this will become like this, after rotation this is k equal to 1. So delete the kth element from this. So this is the simple question now. Okay, I think so. Let me show you the code first. Okay, so what we are doing is, L is the size of array, L is the size of vector. Okay, so I have inserted at, this is the position, this is, and this is the value that you want to insert. So in the vector I want to insert at this position, ar dot begin means in the starting I want to insert this value. This value means ar dot back. The ar dot back means the last value of vector. Okay, after inserting, what I have done is like I have inserted this 6 here. So now there is no work of this 6, so we have to delete this. Okay, so now this ar dot opaque. So now the last 6 is deleted. So there are two conditions, as I have explained. There are two conditions. First one is if k is greater than L. So if k is greater than L, so like k is 5 and L is 2. L is the size of vector. So if size is less than k, so how can we delete the kth element? So what we will do, we will just delete the first element. Erase ar dot weekend. Here you use a iterator. Don't write as 0, because this will not, that will not work. So here we write the position iterator. Ar dot begin means iterator of first position in the vector. Okay, this is the one thing. And if a k is less than size, like size is, let's say size is 5, and you have to read the third second, any element that is less than, like their size is 5, 1 2 3 4 5, and you have to delete a second element from last. So 1 2, so this element you can easily delete. So what we will do you know, like in vector, like suppose this so this is arr dot begin, this is arr dot r begin, and this is arr dot end. This, there is no element, but this iterate, this position iterates, like arr dot end point to this position. Okay, so we want to delete kth element from last. Okay, so for this, what we will write, what we can write, ar of, like if you want to delete the first element from last, so what we can write, arr dot end minus 1 we can write, or not we can write. If we want to read the second element, what we will write, you will write arr dot end minus 2. Same way, if you want to read kth element from the last, so what we will write, arr dot end minus k. So simply arr dot end minus k. This is the removing the, we are erasing the kth element from last. So after deleting operation, what we will do, size will update, because as we have removed one element, so size will update. So we will update a size with ar dot size, and our k will also increase in each operation. So this will increase. So we are doing in while loop, and this while loop will be running until L is equal to 1. If L is greater than 1, this loop will be continuously running. So when L is 1, like there is only one element left, this loop will break, and we will, there is only one element will be left in the vector. So we will just simply return ar dot arr 0. This is the first element, last element, because there is only one element remaining. So this is the question. It was an easy question, but due to like not proper clarification, it became a very hard and difficult to understand. So this is the problem solution. Now let's talk about the time complexity and space complexity as well. So here we can say, like we are doing this n time, because each time, because in each operation we will removing one element. So after n minus 1 operation, size will be 1 and we loop will break. So we are doing this operation, we are running this while loop n times, and in each time we are doing some inserting operation that takes order 1, removing that also take order 1, erasing order 1, then everything is order 1. So we are taking, ultimately we are taking order n time complexity, because they are, these all are order 1 operation. and we are running this while loop n times, because in one, let me, because in one operation, we are removing one element either from the last k, kth from last, and if size is less than, then first element we are removing. So ultimately we are removing one element in each operation. So after n minus 1 operation, there will be only one element left, and this loop will break. So we are running this loop, or to be precise, this we are running this loop n minus 1 times. And these all are order 1 operations. Okay, these are order 1 operations. So time complexity will be nothing but order. And let's talk about space complexity. We are not creating anything, and we are just using the same array, and we are just defined two variables l and k. So we have not created any array vectors, nothing we created, we just using the same and same again. So time complexity will be nothing but order 1, constant extra space, because l and k are the two variables that we are only using. So that's why space complexity will be order 1 and time complexity will be order n. And here you can say in the question also, the required time complexity is order n, and required expected space complexity is order 1. Okay, so this is the solution. So I hope I have cleared everything. So sometimes it is in the question it was not clear what to do. So don't afraid from this. Keep working hard and practice more. Thank you guys. Please subscribe my channel and please like the video. Bye.